Welcome to Formula 1 Maths. This is lesson 1.1, A-Level Further Pure Maths, Year 1. In today's lesson, we are going to learn about imaginary and complex numbers. So let's get started. In maths, there are positive and negative rational numbers. Examples: 3 minus 20, half, and 3/4. There are also positive and negative irrational numbers. Examples: square root of 3 and minus square root of 5. When you combine these two, you get a third set called real numbers. So, rational numbers and irrational numbers are subsets of real numbers. But there is another set of numbers that is outside this set of real numbers. Let's consider this equation here. X squared plus 1 is equal to 0. This has no solution in the set of real numbers. So let's look at the solution. This is given by this I. Now, if you are using an ordinary calculator, the square root of minus 1 will give you a message saying maths error. But here in further maths, we have a value for it, and the value is I. It's kind of awkward using a letter to represent a number, but that is a definition of an imaginary number. So I is an imaginary number. That means I squared. So from here, you can see that I squared is equal to minus 1. If you combine real numbers and imaginary numbers, you form yet another set of numbers called complex numbers. This is denoted by the letter C. So let me give you examples of complex numbers. 9 plus 2i, where 9 is the real part and 2i is the imaginary part. Again, 2 is the real part and minus I root 7 is the imaginary part. Pi plus 3i. Pi is the real, 3i is the imaginary part. Complex numbers are often represented by the letters Z and W. For a complex number, Z equal to A plus BI, this notation here, RE bracket Z, is used to denote the real part. And IM into bracket Z is also used to denote the imaginary part. We can add and subtract complex numbers. How do we do that? Just add or subtract the real parts and add or subtract the imaginary parts. Let's do an example. Given that Z is equal to 10 minus 9i and W is equal to 8 plus 7i, find A, Z plus W, B, Z minus W. So for A, if you write it this way, 10 minus 9i obviously is a Z, 8 plus 7i is the W. All you do here is to collect like terms to get this, and then simplify to get 18 minus 2i. So this is how you add complex numbers. So it would be good to pause the video right here and try B by yourself. So I hope you did that. So let's go now and see the answer for B. So Z minus W is this minus that. Make sure you put 8 plus 7i into brackets, just because of the negative sign here. So now we expand together, collect like terms, simplify, and we get our final answer, 2 minus 16i. We can also multiply a real number by a complex number. How do we do that? Simply expand the brackets. Example. Given that Z is equal to 10 minus 9i and W is equal to 8 plus 7i, find A, 5Z, and B, minus 6W. So 5Z can be written as this, and all you do is expand the bracket to get that. Now pause the video again and try B by yourself. Okay, let's go and find the answer for B. So you've got this. If you do your expansion, you're going to get minus 48 minus 42. And this is how you multiply a real number by a complex number. Now, powers of I. I to the power 1 is obviously I. I squared, as we've seen, is equal to minus 1. If you keep I, you're going to get minus I, because I cubed, as you can see, is I squared times I because of the loss of indices. But you know that I squared is minus 1 times that, and I'm left with minus I. So in the same way, we can simplify I to the power 4 to get 1. So in this case, I to the power 4 is equal to I squared times I squared. This is the same as minus 1 times minus 1, and I get 1. And the same way we can get I for I to the power 5. And I to the power 6 is minus 1. I to the power 7 is minus I. And I to the power 8 is 1. For I to the power 6, you could have evaluated it this way. I squared times I squared times I squared, according to the law of indices. That would be minus 1 times minus 1 times minus 1. So that would be 1 times minus 1, and I get minus 1. So this is how we got minus 1 here. And there's something I want you to note. There's a pattern here. So I to the power 1 is I squared minus 1, I cubed minus I to the power 4 is 1. So we should put an equal sign here and over there. So if you look at it critically, there's a repeated pattern here. So you see here, same thing, I to the power 5 is the same as that one over there. I to the power 6 minus 1 over there. I to the power 7 minus I over here. And I to the power 8 is 1 over there. So what I'm trying to say is this. If we find I to the power 9, I'm supposed to get I over here. So that would be I to the power 4 times I to the power 4 times I. I to the power 4 is 1 times 1 times I. And that would be 1 times I, which is I. And so the pattern repeats itself. Now let's do some example. Example 3. Simplify the following. So 2I all raised to the power 6. This can be written as 2 to the power 6 times I to the power 6. 2 to the power 6 is 64. I to the power 6 is minus 1. So we get this. And final answer is minus 64. Again, it would be a good idea to pause the video and finish off P and example 4 before you proceed. So hopefully you've done that. Let's go and see the answers. 3I to the power 4. This simplifies to 3 to the power 4 times I to the power 4. 3 to the power 4 is 81. I to the power 4 is 1. So we get this. For number 4, we first rewrite this one as 5 to the power 3 times I cubed. Then this one is 125, so we're going to get 125 I cubed minus 5 I cubed. That will give you 120 I cubed, and then I cubed we know is minus I, so we get that, and finally we get minus 120 I. So this is how you simplify using powers of I. We can now solve quadratic equations with real coefficients, even when the discriminant b squared minus 4ac is less than 0. Normally for a quadratic equation, if the discriminant b squared minus 4ac is less than 0, you do not have a solution. But now we can do that. So for example, solve this equation here. So if we do that, we're going to take 25 to the other side to get this. And then we find the square root to get plus or minus square root of 25. This simplifies to plus or minus square root of 25 times minus I, minus 1. And then this will give you that. And finally you get plus or minus 5I. Example 6. So here we can either use completing the square or the formula. So let's see how to use a completed square here. So you start your completing the square like this. Simplify to get that. Take 25 over to the other side to get minus 25. Find the square root to get plus or minus square root of minus 25. And then that simplifies to this. Take the 4 over and you get minus 4 plus or minus 5I. And this is the answer to this equation here. Now let's try using the formula. So using the quadratic formula, which is this, we just substitute our values for b, a, and c. We know that b is 8, a is 1, and c is 41. So let's do the substitution. Get that, simplify to get this, simplify further to get this, and then you can factorize the 2 out, And now we can cross out these 2 and that's 2. And we end up with the same answer we got using completing the square. So this is how we solve quadratic equations, even when the discriminant is less than 0. So there's some independent work for you to do. And this is the time when you pause the video, do the exercises, and then proceed to continue with the video. So I hope you've paused the video and you've done it. Now let's look at the solutions to this. So first one, simplify the following. Square root of minus 63. That simplifies to that. To get this, because the square root of 9 is 3, and you get 3i square root of 7. Please note how I've written this thing here. You may be tempted to write it this way: 3 root 7i. That is correct, but this is not equal to 3 square root of 7i with the I under the square root sign. They are two different things. So to avoid that confusion, we tend to put the I right here, as we did in this answer here. So please note that. So this will give you square root of 100 times minus 3. That will simplify to give you that, and obviously you're going to get 10i root 3. For number 2, it's good to rewrite the question like this. Then you can easily divide this and divide that to get 3 plus 9i. For B, again, simplify it by rewriting it. Minus 10 over 2 plus 5 over 2i. For this side, for that side, minus 6 over 2 is over there. Because this is a minus and that's a minus, you get a plus here. 2i over 2. That simplifies to this. Collect like terms. And you're going to get minus 8 plus 7 over 2i. Now this last question, question 3. Now because the question says that the equation is where n is a real number, has distinct non-real roots, find the range of possible values of that. So we know that for non-real roots, the discriminant b squared minus 4ac is less than 0. So we use that knowledge to go and write our discriminant, which is this. So in this case, our b is n, our a is 1, and our c is 20. So this is the discriminant for this equation. And we know that because it has non-real roots, it must be less than 0. So simplify that, you get that. And then take 80 over to the other side. N is less than plus or minus root 80. You could simplify that to get plus or minus 4 root 5. And then, as you know from GCSE, do a sketch. And this thing here is the one we are sketching. This one, not this one here. This is the one we are sketching. This is a quadratic in terms of n. And the positive coefficient of n squared means that it has a minimum point. And the two values here means that we've got one here, we've got another one here. This is minus 4 root 5, and this is 4 root 5. And because n is less than this, so this is must fall below the x-axis or the horizontal axis. We can state our answer as this, between this and that, because the part of the curve that is less than the horizontal axis is all this side here. And that is the end for this lesson. Thank you for watching. I'll see you in the next lesson.